The story begins not with an explosion, but with a pause, a moment when the instruments hesitate, when the numbers arrive looking correct yet feeling wrong, when scientists, accustomed to steady patterns and predictable margins, find themselves staring at data that refuses to settle into expectation. For centuries, humanity has treated the Earth as a reliable companion. Complex, yes. Powerful, certainly, but ultimately understandable. We mapped its currents, charted its magnetic breath, measured its seasons, and learned to trust the quiet regularity beneath its storms. The planet, we believed, followed rules. And rules could be learned. But what happens when those rules begin to loosen? In laboratories, observatories, and remote monitoring stations scattered across the globe, researchers have begun to notice something subtle but unsettling. Systems once thought independent now shift together. Movements expected to take centuries unfold in decades. Behaviors long confined to theory slip into reality without explanation. Nothing announces itself dramatically. There is no single day when the world feels different. Instead, the change arrives like a misremembered detail, small enough to doubt, persistent enough to return. A compass needle drifts where it should not. A current hesitates, then turns. A storm forms where physics says it cannot tit. Each anomaly taken alone seems survivable, an error to be recalibrated, a footnote awaiting correction. Yet together they form a pattern that resists dismissal. This is not a story about catastrophe, not a warning carved in headlines or fear sharpened into spectacle. It is something quieter, more intimate. A story about uncertainty, about what it feels like when understanding lags behind observation, and confidence gives way to humility. The Earth has always been dynamic. Continents move, poles wander, ice advances and retreats. These truths are not new. What is new is the pace, the coordination, the sense that systems once buffered by time are now speaking over one another, interrupting a conversation that had seemed orderly. For scientists trained to search for causes, the absence of clear explanation is deeply uncomfortable. Models strain, assumptions bend, language softens. Words like anomaly, deviation, and unexpected begin to appear more often than resolution. And yet, beneath the frustration, there is wonder. Because uncertainty is not ignorance, it is invitation. Long before satellites and sensors, humans looked to the natural world with awe rather than authority. The sky was not a data set, the ocean not a system. They were forces to be listened to, not solved. Somewhere along the way, mastery replaced curiosity. Control replaced conversation. Now, quietly, the Earth seems to be reminding us of something older. That knowledge is provisional. That understanding evolves. That certainty is not the same as truth. This documentary is not an attempt to explain everything. It will not offer hidden answers or secret conclusions. Instead, it traces moments where certainty fractures, where observation runs ahead of theory, and humility becomes the most honest response. Across 14 chapters, we will follow signals that do not align, movements that defy expectation, and questions that resist closure. We will listen to scientists not as authorities, but as witnesses. We will explore not just what is changing, but how we respond when the ground beneath our understanding shifts. Because perhaps the most important story here is not about the planet at all. It is about us. How we confront mystery, how we live with not knowing, how we choose curiosity over fear when the familiar begins to blur. If the Earth is changing in ways we do not yet comprehend, the question is not only what is happening, but what kind of listeners we are willing to become, and whether we are ready to hear what uncertainty has been trying to tell us all along. It started with a drift, quiet, almost imperceptible. At the edge of the Arctic, the magnetic North Pole began to move. For most of modern history, it had wandered slowly, a few meters each year, tracing a gentle arc across the frozen landscapes of Canada. But around the year 2000, that arc began to sharpen. Then it accelerated, 40 meters per year, then 50. Navigation systems, once calibrated to a stable Earth, began to fail. Satellites issued corrections, airports repainted runways. Military guidance systems required emergency recalibration. The world magnetic model, designed to be updated every 5 years, now needed revisions every 12 to 18 months. And still, the pole surged onward, toward Siberia. Dr. William Brown, a geophysicist with the British Geological Survey, admitted something rare for someone in his field. This behavior, he said, is without precedent. In the geological record spanning hundreds of thousands of years, nothing matched the current pace or pattern. And even more unsettling, while the North Magnetic Pole raced eastward, the South Magnetic Pole had begun its own acceleration in the opposite direction, as if the entire magnetic skeleton of the Earth were shifting in ways no one had predicted. The poles are not just cartographic curiosities. They anchor a field that shields our planet from radiation, steers the migration of animals, and guides the algorithms in our smartphones. It is a silent force, everywhere and nowhere, assumed to be reliable, until it isn't. Swarm satellites operated by the European Space Agency began to pick up more than just drift. They detected weakening in the magnetic field, particularly over the South Atlantic, where protection against cosmic rays has thinned alarmingly. Meanwhile, over Siberia, the field was strengthening. The contrast painted a picture of imbalance, of something deep within the planet stirring. Then came the anomalies. Arctic terns, birds that navigate thousands of miles each year using magnetic cues, began to arrive hundreds of miles off course. Whales beached themselves in record numbers, often along coastlines that coincided with areas of rapid magnetic flux. Pilots flying over Canada and Siberia reported instruments swinging wildly, 20-degree discrepancies between compass readings and GPS. And deep beneath the Earth, 1,800 miles down, Swarm detected something stranger still, pulses. Rhythmic bursts of magnetic energy occurring every 6 to 8 months, too regular to be random. Scientists began calling them magnetic jerks. They defied every assumption about the core's behavior, suggesting not turbulence, but something like intention. Even earthquakes appeared to be listening. Seismic activity began to shift. Earthquakes occurring not along familiar fault lines, but along paths that mirrored the magnetic changes above. Regions once quiet rumbled with new frequency, as if responding to forces not of plate tectonics, but of invisible fields wrapping the planet in lines we were only beginning to notice. It was no longer just about north and south. It was about the coherence of the whole. If the magnetic field, long considered stable over millennia, could reorganize itself in mere decades, what else might be more fragile than we assumed? And what systems, biological and technological alike, might already be responding to shifts we've only just begun to understand? In the flickering compass, the lost migration, the sudden quake, something speaks, not in words, but in alignment and misalignment, in pulses and quiet drift. Not a warning, but a question. What happens when the ground beneath our orientation begins to move? And how do we find direction when the very field that gives us direction starts to dissolve into mystery? High above the Earth, invisible rivers carry the sky's breath. Atmospheric rivers, narrow corridors of concentrated moisture, are not new. Meteorologists have long documented their presence over oceans, where they move water vapor with the power of 100 Mississippis, feeding storms and shaping coastlines. They are the veins of the weather, pulsing with oceanic energy. But in 2023, something happened that shouldn't have been possible. An atmospheric river formed over the central Sahara Desert. There was no ocean to feed it, no humidity to sustain it. And yet satellites watched in astonishment as a ribbon of vapor, 300 miles wide, snaked across arid land. It held moisture levels exceeding 250% of what local air could support. It persisted for days. And it rained. Not a mist, not a drizzle, torrential rain. 4 to 6 inches in less than 24 hours, falling on a landscape that had not seen meaningful water in years. The desert bloomed, then flooded. Dr. Marty Ralph, one of the foremost experts on atmospheric rivers, called it physically impossible. The equations didn't work. Moisture should have evaporated immediately over the hot sands. The Clausius-Clapeyron law, which describes how vapor behaves with temperature, simply didn't apply. Yet the river in the sky moved with eerie calm, maintaining its structure, gathering moisture as it drifted inland. But from where? Traditional meteorology offers no answer. No nearby ocean, no sufficient wind pattern, no known mechanism to explain how such a system could exist. It wasn't an isolated incident. Other atmospheric rivers began appearing over the Gobi Desert, Central Australia, the American Southwest. Each one defied evaporation rates. Each one carried more water than local air should allow. The moisture didn't match any known oceanic isotope signatures. It wasn't just misplaced water. It was, by every scientific measurement, anomalous water. Radio sondas and satellite data revealed electrical activity inside these desert rivers, patterns unlike any natural storm. Radar showed electromagnetic signatures more consistent with technological signals than weather systems. Moisture held its gaseous form at temperatures that should have forced condensation. Then, as if on cue, it fell all at once. As if waiting, as if responding. Pressure readings showed gradients that violated hydrostatic equilibrium, as if something unseen was holding these systems aloft. Some scientists whispered of artificial influence. Others warned against speculation. The mystery deepened as these rivers began to correlate with solar activity. Within 24 to 48 hours of solar flares, atmospheric rivers appeared over deserts, drawing moisture from unknown sources, moving with coherence, behaving as though guided by some external rhythm. But perhaps the most disorienting discovery came from the rain itself. Chemical analysis of the precipitation revealed isotopic fingerprints that didn't match any known hydrological cycle. The water, its very structure, did not belong to this loop of evaporation and return. It had never been part of ocean or river. It was, somehow, foreign. What does it mean for water to be impossible? To fall where it shouldn't? To form without cause, to travel against every principle we've come to trust about our atmosphere? For now, meteorologists continue to observe. The models do not fit. The maps stretch to accommodate paths once unthinkable, and somewhere above us the sky draws new lines, not just of weather, but of wonder. If moisture can manifest where no ocean breathes, what other invisible systems might be at play? And how do we prepare for a climate that no longer plays by the rules we thought we understood? Beneath the surface, the ocean speaks in currents. For centuries, sailors trusted the Gulf Stream, a colossal river within the sea that carries warm water from the Gulf of Mexico up the Atlantic coast and across to Europe. It was steady, powerful, and predictable. A planetary metronome moving 150 times the volume of the Amazon River. Then, in 2019, something changed. The current stuttered, swirled, reversed. Segments of the Gulf Stream, long thought immovable, began flowing in the opposite direction. Not momentarily, not as a seasonal quirk. For months at a time, massive sections of warm water turned southward against every rule of thermohaline circulation, defying the Coriolis force and centuries of observation. Eddies, vast as entire states, spun where they shouldn't. Some reversed their usual direction. Others lingered, their patterns detached from wind or tide. Satellite altimetry from the Jason-3 and Sentinel-6 missions revealed that sea surface heights were no longer following gravitational norms. In some places, ocean bulges formed without cause, tides without moons, waves without wind. And the water was warm, too warm. Even when flowing backward, these rogue segments retained temperatures between 20 degrees and 25 degrees Celsius. Thermodynamically, it didn't make sense. Energy should dissipate, heat should redistribute. But the heat stayed where it wasn't supposed to be, as if insulated by forces not accounted for in any model. Marine biologists began to notice unsettling shifts. Tropical fish turned up in the icy waters off Nova Scotia. Coral species, usually confined to the Caribbean, were spotted far north of their ranges. Plankton communities, those microscopic architects of the marine food web, began to behave strangely, changing composition before physical changes in the water were even detectable, as if they sensed what instruments could not. At depths of 3,000 meters, where calm and stability once reigned, deep-sea probes found mirrored anomalies. Temperature and salinity changes echoed surface currents instantaneously. That's impossible, oceanographers said. Surface turbulence doesn't reach those depths so quickly. Yet the data was clear. The whole water column was changing in synchrony. Acoustic Doppler current profilers recorded flow speeds that exceeded theoretical limits. Energy was moving faster than the system could explain. And then came the correlations. Every time a segment of the Gulf Stream reversed, geomagnetic satellites detected disturbances, subtle electromagnetic pulses rippling through the magnetosphere. Not solar storms, not cosmic interference. These pulses originated from Earth itself. And within 12 to 36 hours, the ocean responded. The cause and effect logic began to blur. Was the ocean reacting to magnetic change? Or were both responding to something deeper? Then there were the plankton again, tiny, ancient, and quiet. Long before satellites noticed the reversals, these microorganisms had begun migrating, as if alerted, as if in communion with the ocean's deeper rhythms. And if plankton could feel the change before we did, what else might be listening? The Gulf Stream, once a metaphor for constancy, now raises questions that ripple outward. What happens when the Earth's most dependable flows betray their course? When the map drawn by centuries begins to dissolve? This is not just an oceanographic mystery. It is a reminder that the systems we consider stable are only as stable as the forces we believe govern them, and that those forces may be shifting, unseen, beneath the surface. In the quiet turn of water, in the swirl of a reversing tide, something old is whispering. The ocean remembers. But it does not promise consistency. And in that uncertainty, a new understanding begins to take shape, one that may upend more than just our maps, but the very rhythm by which we understand the living Earth. In the far north, the ground is supposed to sleep. Permafrost, frozen soil locked beneath the Arctic surface, has long been regarded as a time capsule, a cold archive preserving millennia of climate, biology, and carbon. It thaws slowly, if at all, and is expected to melt only with steady, long-term warming. Although so. But now that cold silence is breaking. And not in the way anyone anticipated. Across Siberia, Alaska, and the Canadian Arctic, researchers have documented a paradox. Permafrost is melting at unprecedented speeds in some regions, while inexplicably deepening and expanding in others, sometimes just miles apart. In the same borehole, at the same moment, surface layers can be warming by 3 degrees per year, while deeper layers cool just as rapidly. Thermal inversion in frozen soil. A contradiction in the laws of heat transfer. Dr. Vladimir Romanovsky at the University of Alaska, Fairbanks, measured these shifts firsthand. We're seeing behavior, he said, that doesn't fit any model. It's like the ground is choosing which parts to melt and which to preserve. Ground-penetrating radar reveals shifting boundaries that move not with seasons, but with daily cycles, sometimes leaping 50 meters overnight. These changes occur independent of surface temperature, solar input, or even soil composition. Something deeper, stranger, is at work. Methane levels are spiking. In some zones, permafrost is releasing methane at rates 100 times higher than normal. But nearby areas under similar conditions are absorbing carbon dioxide and nitrous oxide instead, acting as unpredictable atmospheric filters. The chemistry varies dramatically over short distances, challenging the idea that frozen ground is passive. And then the dating anomalies appear. Carbon samples taken from permafrost cores reveal impossible timelines, surface materials dating thousands of years older than the layers beneath. Geological principles say this can't happen. The Earth's history, layer by layer, is meant to be sequential. But here, the record is scrambled. Thermal imaging from satellites like Landsat and MODIS shows surface temperatures that disagree with ground-based sensors by up to 25 degrees Fahrenheit. Either the Earth is hiding its heat or something is masking it from detection. Then come the microquakes. Sensitive seismic equipment records tiny tremors in the permafrost, structural shifts that occur faster than expansion or contraction can explain. The mechanical properties of the frozen ground itself appear to be changing. Ice and soil, once predictable composites, now behave like unfamiliar materials. Electromagnetic surveys add yet another layer of confusion. Electrical conductivity within permafrost varies independently of both moisture and temperature, violating basic physics. Phase transitions are occurring that do not align with the known behavior of ice or water. This is no longer simply about thawing. This is about a system responding to something we cannot yet define. The permafrost has always been a threshold between past and present, frozen and alive. But now, it seems to be more than a boundary. It is a signal, a living sensor responding not just to temperature, but perhaps to the planet's deeper rhythms, magnetic, seismic, atmospheric. And in that signal is a warning. The Earth's coldest places are no longer stable. They are active, responsive, and possibly trying to tell us something. That change does not always follow heat. That time does not always move forward. That even the ground beneath our feet may remember more than we expect and reveal it in ways we cannot yet explain. High above us, beyond the familiar blue sky, lies a veil of charged particles that hums with silent electricity. The ionosphere, stretching from about 50 to 400 miles above Earth, is a realm of plasma and light, a shimmering shell that protects us from solar radiation and guides the path of radio waves. It is delicate, dynamic, and crucial to life below, and now it is behaving in ways no one can explain. During periods of normal solar activity, when sunspots are few and flares are quiet, Earth's ionosphere should remain relatively calm. Yet, over the past decade, scientists have observed bursts of electrical energy in this region that exceed expectations by factors of 10, even 100. These aren't random fluctuations. They are structured, coherent pulses, electrical surges stronger than what the sun provides, appearing in patterns too consistent to be dismissed as noise. Dr. Jeffrey Forbes at the University of Colorado has studied the ionosphere for decades. We're seeing energy levels, he notes, that shouldn't exist without an external driver. But the sun is quiet, and the Earth is silent. So what's powering it? Very low-frequency radio transmissions designed to study this layer have begun returning signals distorted in unexpected ways. Satellite communication systems report delays and errors that do not correspond to known sources of interference. No storms, no flares, no auroras. Just silence, and yet disruption. High-frequency radar arrays, like those used by the Hargout ERP project and the IceScat facility in Europe, have detected plasma patterns moving in geometric forms, triangles, grids, hexagons. These shapes hold for hours, defying the turbulence of the upper atmosphere that should scatter them in minutes. Temperature readings reveal regions of the ionosphere heating to over 3,000 Kelvin during times of minimal solar radiation. Entire zones glow with invisible heat, untethered from the cycles we thought governed them, and the electrical imbalance spreads downward. The global electrical circuit, the invisible loop connecting the Earth's surface to the upper atmosphere, has shifted. Normally held at a steady potential difference of 250,000 volts, some regions now spike past 500,000 volts. Lightning patterns across the globe are changing. Storms form under blue skies. Discharges leap between cloudless horizons. Worse still, electromagnetic pulses have been detected descending from the ionosphere, not radiating outward into space, but pressing down toward the surface. Unusual bursts that resemble radio transmissions in frequency and structure, yet emerge from regions where no human technology operates. GPS systems suffer. Position errors increase tenfold in some areas, rendering satellite navigation unreliable in regions where accuracy once measured in inches. The distortions come not with storms or interference, but with eerie regularity, like a beat, pulsing unseen. Correlations emerge. Earthquakes often precede ionospheric disturbances by hours, suggesting a coupling between the deep Earth and the high sky. As if seismic energy is mirrored in the atmosphere, carried not by rock or wind, but by fields we barely comprehend. And the ionosphere itself? It holds more electrons than it should, densities that rival those during solar flares, even when no flare has occurred. The source remains unknown. It is as though Earth's upper atmosphere has become a self-energizing system, a layer no longer simply reacting to solar weather, but generating its own. A question lingers, unspoken in academic papers, but present in every anomaly. What if the ionosphere is not only responding to terrestrial and solar forces, but to something else? Something we haven't yet measured or understood. Perhaps the sky above is not just a boundary. Perhaps it is a mirror, reflecting back to us the complexity and the mystery of a planet that is far less passive than we once believed. And in that mirror, a new truth begins to emerge. The forces that govern our world may reach far beyond what we see, linking ground to sky in ways we've only begun to imagine. Gravity is the quietest of forces, invisible, constant, trustworthy. It tethers us to the Earth, guides the planets in their dance, and holds the universe in its shape. But what happens when gravity itself begins to flicker? Across multiple continents, gravimeters, some of the most precise instruments ever built, have begun to register changes in Earth's gravitational field that defy explanation. Tiny fluctuations occurring daily, sometimes hourly, not at the edge of black holes or neutron stars, but in forests, cities, and deserts. Dr. Carla Breitenberg, working with sensitive Lacoste and Rumberg gravimeters, documented gravity shifting by as much as 5 to 200 milligaules within 24-hour periods, changes that should require the movement of billions of tons of mass underground. Yet no seismic activity, no geological collapse, no movement of any kind was detected. Gravity appeared to be changing without mass, a violation of Newton's law, a crack in the fabric of general relativity. Worse still, these anomalies were not isolated. Gravimeters, placed thousands of kilometers apart on different continents, recorded synchronized fluctuations. Gravity, which by every theory should respond only to local mass, was behaving globally. Fluctuations in South America matched those in Africa and Asia within seconds. This wasn't a local disturbance. It was as if gravity itself was pulsing. Satellites from the GRACE follow-on mission, designed to track global gravity changes by measuring the distance between twin satellites down to a micron, confirmed it. Entire regions of Earth's gravitational field were rising and falling without corresponding changes in mass distribution. And wherever these anomalies occurred, strange weather followed. Atmospheric pressure systems emerged suddenly, wind patterns shifted. Temperature inversions developed in the absence of known meteorological triggers. It was as though gravity was not just pulling on matter, but influencing the air, the light, the very balance of the sky. In some zones, atomic clocks, our most stable instruments of time, began to drift. Time, which dilates slightly under stronger gravity, was shifting by 20 to 40% more than theory predicted. These were not errors. They were measured, repeated, undeniable. Tides, too, betrayed their origin. In coastal areas near gravity anomaly zones, sea levels no longer matched predictions based on the moon's position. Tidal patterns behaved as if pulled by invisible masses or redirected by unseen hands. Then came the underground surveys. Borehole gravimetry, meant to chart the density of rock layers, revealed structures that changed from week to week. Masses appeared to shift or vanish, violating the conservation of mass. Entire geological formations moved, or simply weren't there, despite being previously mapped. And behind the math, a whisper of pattern. The gravity changes followed rhythms, periodic oscillations, modulation sequences, frequencies, more reminiscent of technology than nature. As if the planet's deepest forces were playing a song we hadn't yet learned to hear. In controlled laboratory experiments, these fluctuations persisted. Shielded from electromagnetic interference, in vacuums and temperature-controlled environments, gravimeters still responded to some invisible tide. The effect could not be turned off. Gravity, once the cornerstone of certainty, had become fluid, and the implications were profound. If gravity can shift without mass, can time flow without cause? Can space curve in ways unrelated to stars or planets? Or is something else touching the lattice of spacetime, something unrecognized, operating not from above, but from within? These questions remain unanswered. But one truth is becoming harder to ignore. We are no longer measuring the world we thought we knew. We are witnessing a planet whose most fundamental force is beginning to behave like a message, and we have only just begun to listen. The sky flashed, but there were no clouds. Over the dry plains of central Australia, during a season of record-low humidity, lightning struck the earth. Not once, not as a freak event, but in bursts. Bolts arcing from empty air to sand, each carrying the power of a thunderstorm, erupting from a sky as clear as glass. This is not how storms are supposed to work. Lightning, by every textbook, requires contrast, moisture, instability, a churning cloud of rising heat and falling ice, a charge separation that builds tension until it cracks. But increasingly, scientists are documenting lightning that forms without those ingredients, discharges that defy the fundamental rules of atmospheric electricity. Dr. Earl Williams, a researcher at MIT's Lincoln Laboratory, has studied these clear-air lightning events with growing concern. The energy they release rivals traditional thunderstorms, yet they form in air too dry, too stable, too empty to support the known mechanisms of electrical charge. Electric field monitors show voltages building in regions with no storms in sight. Some lightning strikes originate not from clouds, but from a layer of charged atmosphere itself, leaping downward from nowhere. And the patterns are growing. Global lightning detection networks, like the Worldwide Lightning Location Network, have recorded a 15 to 25% annual increase in lightning frequency over regions experiencing less precipitation. In short, more lightning where storms should be fewer. Drier skies. More fire. The anomalies deepen. Radio receivers tuned to monitor lightning's radio frequency pulses are picking up strange signals, regular, rhythmic discharges in frequencies between 8 and 30 kilohertz. These are not random cracks of nature. They resemble signals, pulses with structure, timing sequences more akin to human-made transmissions than the chaos of a thunderstorm. And they are coordinated. In 2024, lightning storms were recorded on 3 continents, Africa, South America, and Southeast Asia, within seconds of each other under identical atmospheric conditions: clear skies, low humidity, no known storm systems. The discharges occurred simultaneously across thousands of miles, as if responding to a shared signal. It's not just up there, it's down here, too. Ground current sensors placed near strike zones show electrical flows that persist long after the lightning fades. Currents of 10 to 100 amperes move through soil for hours, implying that the atmosphere is not just discharging, but sustaining an unknown source of power. These atmospheric surges affect more than air. During these events, ionospheric sensors detect disturbances, suggesting a coupling between Earth's upper layers and its surface through vertical channels of energy no one fully understands. And the chemistry changes. Air samples taken during anomalous storms reveal strange reactions, unexpected spikes in ozone, nitrogen compounds, even traces of molecular changes that require energy levels far beyond those measured in the strikes themselves. Something is amplifying the energy, or sustaining it from an unseen reservoir. Then there is the light. Ball lightning, normally rare and fleeting, is being seen more often, lingering longer, not seconds but minutes. Floating spheres of plasma that maintain coherent shape, color, and movement patterns, as if guided by a logic no storm should possess. And the global electrical circuit, the atmospheric loop that connects the surface to the sky, is running hot. Measurements show it operating at 50 to 100% above historical voltage baselines. Where is the energy coming from? How is the sky electrifying itself without weather? And if this storm is not meteorological, what kind of system is it? Perhaps we are no longer watching weather. Perhaps we are observing a phenomenon that lives in the spaces between systems, between sky and ground, silence and spark. A reminder that even the clearest skies may be charged with hidden potential, and that in every flash without thunder, nature is writing a new script, one we've only just begun to read. It began with a compass spinning in circles, not just one, but many. From ships in the southern Indian Ocean to hikers in northern Canada, reports surfaced of magnetic readings that made no sense. Compasses that reversed direction, magnetometers that swung wildly from one pole to another, and GPS devices disagreeing with every needle. The Earth's magnetic field has always shifted slowly. Over thousands of years, it reverses polarity. North becomes south, and vice versa. But what scientists began detecting in the early 2020s was something different. Not a slow, planet-wide transition, but rapid local magnetic flips, occurring in hours, sometimes minutes. Dr. Monika Korte at the GFZ German Research Center for Geosciences documented one such event in Patagonia, where an area the size of a small country experienced a full magnetic polarity reversal in under 48 hours. The magnetic field didn't just weaken, it inverted. North became south, then flipped back again. This wasn't a one-time glitch. Across multiple locations, from Mongolia to Argentina, Siberia to the mid-Atlantic, satellite and ground data began to show temporary but complete magnetic flips. These were not tied to solar storms, not triggered by shifting iron flows in the outer core, and not explained by any known geophysical model. Migratory species responded first. Birds tracked via satellite veered hundreds of kilometers off course in reversal zones. Sea turtles, dependent on magnetic cues to return to nesting beaches, stranded en masse. Whales followed, beaching themselves repeatedly near magnetic reversal regions. Something deep in their evolutionary wiring had lost its compass. And the anomalies intensified. Magnetic field strength in some areas surged by over 15,000 nanotesla within hours, equivalent to centuries of change packed into a single day. Proton precession magnetometers, designed to measure even minor changes, recorded swings that broke instrument thresholds. The implications were staggering. Archaeologists attempting to date pottery and ancient fires using archaeomagnetic techniques the magnetic signature locked into heated clay, began getting results that made no sense. Objects known to be from the 18th century showed magnetic signatures from the 13th. Magnetic north, it seemed, had not been where records said it should have been. Even more disturbing, satellite data from ESA's Swarm constellation showed that these local flips were happening in synchrony. Not just one zone flipping, but multiple zones around the world, in rhythm, like coordinated pulses. Geoelectric surveys added another layer. During reversal events, ground currents surged, not randomly, but in distinct paths. The currents didn't match expected patterns from geomagnetic induction. Instead, it appeared the electrical flows were causing the magnetic shifts, not the other way around. This reverses the fundamental principle of electromagnetism. Then came disturbances in the magnetosphere itself, the planet's invisible shield against solar radiation. During localized flips, satellites recorded disruptions far beyond the surface, as if these brief terrestrial events sent ripples into space, disturbing satellites and communication systems thousands of kilometers away. Navigation systems faltered. Aircraft reported deviations between magnetic headings and GPS of up to 30 degrees in reversal zones. Runways needed renumbering. Submarines switched to inertial guidance when their compasses became unreliable. The magnetic field, once thought to be slow and stable, had become erratic and immediate. What causes this? No one knows. Not mantle convection, not core dynamics, not space weather. The phenomenon operates outside the timescales and mechanisms we understand. It behaves as if responding to an influence yet unrecognized, one that does not emerge from Earth's interior, but perhaps moves through it. And in these reversals, a question lingers. If the field that protects us, guides us, and aligns us can shift in an afternoon, what else might be subject to sudden inversion? And if our planet's magnetic heart is no longer steady, how do we navigate a world where even north cannot be trusted to stay still? It was meant to be predictable, a closed loop, the breath of the Earth. Carbon flows through the atmosphere, oceans, soil, and life itself in a cycle as old as the planet. Plants draw it in, animals exhale it, oceans absorb and release. The system is dynamic but balanced, or so we thought. Now that cycle is breaking. At research stations from Mauna Loa to Barrow, carbon dioxide readings began fluctuating with a volatility that defied explanation. Not seasonal rises and falls, but rapid swings, 15 to 40 parts per million, occurring within weeks. The changes were too fast for forests or oceans to account for. It was as if carbon were being added and removed by an unseen hand. Dr. Pieter Tans at NOAA called it a carbon cycle behaving as if it's detached from known processes. Photosynthesis, respiration, fossil fuel emissions, none could explain the erratic patterns now emerging. More anomalies followed. Tower-based analyzers across the Midwest recorded CO2 levels that varied wildly between fields only miles apart, despite identical vegetation, soil type, and land use. Some zones showed sudden absorption, others spontaneous emissions, in patterns that ignored known drivers like sunlight, temperature, or biological activity. Then came the isotopes. Mass spectrometry revealed atmospheric carbon with isotope ratios unlike anything on record. Ratios of carbon-13 to carbon-12 that didn't match fossil fuels, wildfires, or respiration. Some of it appeared alien to Earth's surface processes, carbon that had not been through the biosphere or ocean in any identifiable way. And the oceans, the great carbon sponge, were no longer following their script. Autonomous buoys showed that in some regions, ocean water was releasing CO2 even as atmospheric levels declined. In others, the water absorbed carbon despite already being saturated. This decoupling of ocean-atmosphere exchange violates Henry's law, a basic principle of chemistry. The air and sea were no longer in balance. Underground, the mystery deepened. Soil carbon monitors recorded massive swings, storage levels changing by 20 to 50% within a single month. Microbial activity couldn't account for it. Root systems didn't grow fast enough. The math simply didn't work. Plants, too, were behaving strangely. Eddy covariance towers measuring plant respiration showed photosynthesis rates 10 times higher than what biomass should allow. Trees were either absorbing more carbon than they could process, or something else was moving that carbon through them unnoticed. Modeling these changes produced impossible results. Carbon budget calculations, a cornerstone of climate science, no longer added up. Either the planet was creating carbon from an unknown source or absorbing it into a sink we hadn't found. Either way, the laws of conservation appeared to be breaking down. Worse still, the timing was wrong. Some of the largest CO2 shifts occurred at night, when photosynthesis stops. Concentrations rose or fell with no connection to solar radiation, as if something below or above the biological system was operating its own cycle. Could this be geology, atmospheric chemistry, or a deeper planetary process not yet identified? The implications stretch far beyond climate science. If the carbon cycle no longer behaves according to established principles, then every model built on those assumptions becomes suspect. Forecasts of warming, cooling, feedback loops. Each depends on a system we now realize we may not fully understand. The carbon cycle, once a map of how life breathes, has become a signal, a flickering code etched into air and ocean, soil and leaf. And in that code, a profound question emerges. What if the Earth is doing something new? Or worse, what if it always was, and we've only just noticed the places where our understanding falls short? In a world where carbon no longer answers to the rules we wrote, perhaps the story isn't about emissions alone. Perhaps it is about the limits of knowing and what lies just beyond them. The Earth trembles, but not where we expect. For centuries, seismologists have mapped the restless lines of the planet: faults, subduction zones, and fracture belts where pressure builds, then breaks. Earthquakes follow patterns. They strike where stress accumulates, where plates grind. There is logic in the chaos. But now, that logic is unraveling. In places where the ground should be silent, regions geologically stable for millions of years, seismic activity is rising. Central Australia, the Canadian Shield, the Great Plains of the United States. Flatlands with no known faults now shudder under tremors measuring 6 or greater on the Richter scale. Dr. Seth Stein of Northwestern University was among the first to raise the alarm. "We're seeing major quakes in places that should be dormant," he said. "The crust here is ancient, thick and cold. It's not supposed to move. Yet it does, and not just in isolation. Earthquakes on different continents, separated by oceans, are occurring in synchronized clusters within 24 to 48 hours of one another. Seismic waves ripple across the globe in ways that suggest not independence, but coordination. As if the Earth's crust is responding to something deeper than tectonic pressure. The depths of these quakes raise further questions. Traditional geology holds that earthquakes originate in the brittle upper crust, where rocks snap under stress. But now, seismographs are detecting events more than 600 kilometers down, deep in the mantle, where heat and pressure should render rock too plastic to fracture. And yet, fracture it does. Even more unsettling is how these quakes behave after the main shock. According to Omori's law, aftershocks should taper off gradually. But now, they return in waves, sudden clusters of seismic energy days or weeks after the initial event, as if some hidden hand were reshaping the stress field long after the rupture. Standard prediction models are failing. Algorithms that once forecast the likelihood of future quakes based on past data are now producing error rates exceeding 60%. Patterns once reliable, like foreshock sequences, stress drop estimates, and seismic gaps, are no longer holding. Seismic tomography, essentially a CT scan of the Earth's interior, reveals another layer of mystery. The structures that generate quakes are changing between events. Rocks that were once homogeneous now show anomalies, voids, densities, boundaries that shouldn't form over such short timescales. Some of these zones appear to move. The energy budget doesn't make sense either. Quakes are releasing more energy than plate movements alone can account for. Something else is adding force, amplifying stress, or unlocking energy stored in ways science has yet to define. Perhaps the most troubling discovery is the response of the planet's interior to surface magnetic shifts. Swarm satellites tracking the magnetic field have found correlations between regions of rapid magnetic change and unexpected seismic activity. As if the Earth's magnetic and seismic systems are linked, not just occasionally, but fundamentally. What does it mean when the Earth's foundation moves without reason? When the crust convulses not from pressure, but from influence? We've long thought of earthquakes as the voice of the planet's surface tensions. But perhaps they are something more, an echo of deeper changes, signals from processes operating beyond our reach. A transformation, not of plates, but of the entire planetary system. And as the ground shifts beneath old assumptions, we must face a sobering truth. If we can no longer predict the shaking, how do we prepare for its silence? And what if the silence, too, is no longer trustworthy? Sometimes the most profound mysteries are not in what moves, but in what connects. Across the 10 phenomena we've explored, magnetic flips, rogue ocean currents, atmospheric rivers over deserts, and gravity that pulses without cause, a pattern begins to emerge. Not of isolated anomalies, but of synchronization, a whisper threading through the planet's systems. Earth appears to be reorganizing. This isn't just about climate. It's about coordination. Across disciplines, geology, atmospheric science, oceanography, physics, researchers are discovering that events once thought unrelated are now moving together. Magnetic field surges align with deep earthquakes. Ocean currents reverse in rhythm with solar pulses. Atmospheric moisture behaves as if attuned to invisible tides. Lightning strikes without clouds during periods of ionospheric overcharge. Time itself bends slightly near gravitational anomalies. The rules are shifting. And so is the tone of the scientific conversation. What was once dismissed as outlier data is now treated with curiosity. We're observing something larger than our models allow, one atmospheric physicist remarked. Either we've missed something fundamental, or everything we thought was separate is, in fact, connected. At the heart of this mystery is timing. The planet's systems, magnetic, seismic, oceanic, atmospheric, are accelerating. Changes that would once unfold over millennia now happen in months. Pulses that once seemed random now fall into rhythm. The tempo of the Earth is quickening. Why? One possibility is internal. Perhaps Earth is entering a transitional phase, a tipping point in its own evolution, a shift in its electromagnetic architecture, a rebalancing of forces we do not yet fully understand. Another possibility lies beyond. Solar activity, cosmic radiation, even influences not yet identified, could be interacting with Earth in new ways, modulating its systems like a radio receiver catching a signal. The Swarm, GRACE, and DMSP satellites have all detected electromagnetic events, with characteristics more structured than random interference. But the most daring hypothesis is this, that what we are witnessing is not a breakdown, but a reorganization. Not chaos, but choreography. A planetary system reconfiguring itself, not in parts, but as a whole. In this light, each anomaly becomes a thread in a larger fabric. The Earth is not malfunctioning. It is transforming. And our instruments, our satellites, sensors, and science are finally sensitive enough to notice. This raises uncomfortable questions. If Earth can change its foundational behavior so swiftly, how much of our environmental understanding remains accurate? Are our climate models enough? Are our risk maps outdated? Are we prepared for a planet that behaves less like a machine and more like a living system? These are not conspiracies, they are frontiers. They do not point to fear, but to wonder. Because in every unexplained pulse, every mirrored quake, every upside-down current and wandering field, we are being reminded of something essential, that the Earth is not fully known, and that perhaps it never was. In this realization is a quiet invitation, not to panic, but to listen, to release our need for certainty and return to curiosity, to see science not as a list of answers, but as a vessel for questions vast enough to hold the unknown. And in that space, between what we measure and what we feel, we may yet rediscover the deepest truth of all, that we are not separate from this planet. We are part of its rhythm, its mystery, and its change, and the next chapter of its story will be written not in equations alone, but in how we choose to understand our place within it. It begins, as many things do, with memory. The memory of a bird navigating by stars and magnetic lines, of a whale tracing invisible paths through deep ocean currents, of ancient soil holding carbon from long before our species stood upright. Memory in this sense is not conscious. It is encoded in instincts, in cycles, in the architecture of the Earth itself. But now that memory appears to be shifting. Across every domain we've explored, magnetic poles, permafrost, ionospheric energy, the carbon cycle, one theme endures: the breakdown of predictability. Systems are no longer behaving according to their historical patterns. They forget. Or perhaps they remember differently. It's tempting to frame this as a series of failures, failed models, failed forecasts, failed understanding. But that would be missing the point. What if the anomalies we see are not failures of the planet, but failures of our perception? Take time, for instance, not the abstract concept, but time as measured by atoms and satellites. In gravity anomaly zones, time bends beyond predicted margins. Atomic clocks tick faster or slower than they should. Tidal rhythms skew. These are not metaphorical shifts. They are measurable, and they imply that memory itself, the continuity of cause and effect, may no longer be linear in the way we assume. Or consider biology. Plankton communities react to ocean current changes before they occur. Migratory animals alter paths in anticipation of invisible magnetic shifts. Even plant respiration, tied to light and carbon, is misaligned with day-night cycles in certain zones. It's as if the living systems of Earth are attuned to a layer of planetary information we cannot yet access. We call them anomalies, but perhaps they are anticipations. What if Earth's memory isn't static, but adaptive, not fixed in laws, but responsive to forces we have yet to name? And where does that leave us, humans, with our instruments and equations? It leaves us exactly where we've always been, surrounded by a world that exceeds our understanding, asking us not for control, but for reverence. This is not to say science has failed. Science is how we listen. It is how we learn. But when the data speaks in unfamiliar tones, science must also become humble enough to pause, to wonder, to ask if memory can shift in soil, in sea, in sky, can it shift in us? Can we too unlearn the assumption that the Earth is a passive backdrop to our lives? Can we remember ourselves as participants in a living system, not masters of a static one? Because perhaps these anomalies are not threats. Perhaps they are invitations, a call to awaken from the trance of certainty, to meet the world not just with analysis, but with awe. The Earth is writing a new script, not in words, but in winds that reverse, currents that loop, and skies that spark without clouds. We do not yet know what the plot is, but we are already part of it. The question is not whether we will find all the answers. The question is whether we are brave enough to sit with the unknown long enough for it to reveal something deeper than answers, something like understanding, something like home. In the end, it returns to silence, not the silence of absence, but of depth, of a planet humming with patterns we are just beginning to perceive. For centuries, we looked to the Earth for answers it was never obliged to give. We mapped its surfaces, modeled its systems, and predicted its moods with growing confidence. But confidence is not the same as comprehension, and now we find ourselves in a moment of reckoning. Across magnetic fields and melting ground, shifting skies and reverse currents, the evidence has grown too large to ignore. The anomalies are not isolated. They are interconnected ripples moving through the deep fabric of Earth's systems. What was once a collection of mysteries now reveals a singular truth. The planet is alive in ways we do not yet understand. This isn't a story of collapse. It is not the script of doom we so often expect. Instead, it is a call to humility, a reminder that intelligence does not begin with certainty, it begins with wonder. Because the real question isn't just what is happening to the Earth, it's what is happening to our way of seeing it. When we observe rivers forming over deserts, lightning emerging from cloudless skies, and gravity pulsing in rhythm with no detectable cause, we are witnessing more than climate change. We are witnessing a shift in the conversation between the Earth and its inhabitants. It is not warning us. It is showing us that our models are incomplete, that our measurements, though precise, are not yet wide enough, that our perspective, rooted in separation, needs to evolve toward relationship. And so we return to the central theme that has woven through each chapter: connection. Every anomaly challenges the boundaries we've placed between systems. Magnetic pulses correlate with ocean currents. Seismic activity echoes in the upper atmosphere. Carbon fluctuations trace invisible circuits through life and geology alike. It is not chaos. It is choreography. Earth is not malfunctioning. It is communicating. The message is not written in words, but in behaviors, in accelerations, in synchronizations, in disruptions that are not threats, but invitations, to see the world not as parts, but as pattern. What comes next is not certain. The future will not be forecast by charts alone. It will be shaped by our willingness to listen, to ask better questions, and to sit with the discomfort of not knowing. Because in that discomfort lies a deeper truth. We are not separate from this mystery. We are embedded in it. We are of the earth, made from its dust and water and fire. And as it changes, so must we, not only in how we act, but in how we imagine. In the face of a planet that no longer plays by the rules we wrote, we have two choices. We can retreat into fear and rigidity, or we can move forward with openness and awe, ready to learn, to adapt, and to remember what it means to belong to a living world. The Earth is evolving, not away from us, but around us. And perhaps, just perhaps, it is asking us to evolve with it.